Hi, this is Chuck Martin at the AI Summit in New York City. I have with me here from Wells Fargo, Peter Tsahalis, welcome.
Hi, thanks.
So you're dealing with quantum. Where is quantum in the grand scheme? People keep saying it's coming. Is it here yet?
It's just been born, let's put it that way. We are just now starting to see hardware, the qubit race begin amongst different vendors. But the utility of it is the real question. What can you really do with 100 qubits, 200 qubits, 300 qubits? How much noise or error come out of the implementations that you attempt to do? So a lot of large vendors in this space, IBM being one of the biggest one that's recently expanded their roadmap, predicting qubit counts and error correction rates. So that's what we keep a close eye on. But in terms of, at least in financial services, practical applications, we can't quite implement them yet, but we can experiment and at least prove that they will be valuable someday.
So do you see it as integrated with current computing or as a separate thing?
The way most of us envision it is quantum computing will be another form of compute power. Just like today you can get classical compute power, you can get GPUs for doing AI work. Quantum workloads will be a type of workload that you can, if you can develop your algorithms appropriately, you can send a certain type of work to quantum machines for processing, but there will be, I think for the foreseeable future, there will be an integration with classical computers and quantum computers working in tandem. Some preparation done classically, one aspect of calculation done in a quantum realm, and then some post-processing done classically as well.
Berenice, the editor of Enter Quantum at one of our publications, she's always seeing cybersecurity as a really big deal. What's the play there?
Yeah, so the area of post-quantum cryptography was, I guess, the first thing that everyone started worrying about when it came to quantum tech. Theoretically, when you have a quantum computer with the right capability, number of qubits, noise level, you could in real time snap encryption. That would take weeks, months of a supercomputer today. So how do you prepare for that, right? And how much lead time do you need to prepare for that? And what do you do? So a lot of companies have made the investments first in area of PQC in order to evaluate what they have in terms of algorithms and encryption types and the number of them and the standardization of them. Try to start consolidating them and start looking at solutions that already exist that are at least quantum prepared or quantum safe. A lot of research has been done in the area of crystals. These are algebraic lattices that are very resistant to a quantum type attack. So we believe that you can take steps now to organize yourself and put in some preventative measures that can carry you for the foreseeable future. But it is the most practical place to spend time and energy right now preparing.
So how does a company deal with the bad guys who are capturing this encrypted data, waiting for their quantum computing to decrypt it?
The same way we do already. Like the bad guys capture this data. Sometimes they sit on it for 3, 4, 10 years. That's the scary part. It's not about protecting data today from an attack today. It's about protecting data that may have been stolen today from an attack that might happen 10 years from now on that same data. Hope that makes sense.
Yeah, but how does the company deal with that? It's like chicken and egg, trying to stay ahead.
You protect your data at all costs. That rule doesn't change regardless of the threat vector. You protect your data at all costs.
So what do you look at the timeline? The CTO of FedEx, who spoke here yesterday, he said that yes, they see quantum coming, but they think it's more of a 5-year thing. Some people say, well, we're doing something now. Where do you see the timeline of it?
It's hard to predict these things. I get this question a lot. 5 years from now, if you look at some of the vendor roadmaps, the size and scale of quantum hardware and the expected error correction and mitigation techniques, I think should allow some early use cases to form. It's hard to be more predictive than that because these technology cycles, sometimes they're very steep, sometimes they flatten out for a while. There are still 100 breakthroughs that need to occur before the scale of these machines reaches a point where a financial services firm can really put a lot of heavy compute on it. scientific applications are already entering, a time of quantum utility where certain scientific research where you're modeling a particular element and you're interested in the exact behavior of a qubit under a certain condition, they can actually start to extract valuable research from even 100 qubits today. But when we're talking about optimization problems, predictive research, or predictive problem space, you need to map huge data volume into the system, huge circuit depth. So we're not quite there yet, but in simulators, we can start to make those preparations.
What do you see as some of the most important industries that should be in this? I mean, financial services is obvious. Are there other industries that you think should be or are involved in quantum?
Anytime, if you're in an industry where it would be helpful to you to predict something based on past data, or to profile something like a customer, or to profile something like fraud information, then yeah, there's a use case.
That sounds like everybody.
It sounds like everybody. A lot of the power of quantum isn't necessarily just quantum in isolation. It's the marriage of quantum and the intersection of quantum with AI, blockchain. All these different technologies are going to converge into this sort of supernova type event. A lot of the research we do at Wells Fargo is how do we take AI algorithmic work that's applied classically and translate that into a quantum space. So quantum machine learning, not just regular machine learning. Quantum recurrent neural networks, not just regular one. So we have to reinvent that math and be prepared for it.
So a year from now, we're sitting here having this conversation around quantum. What will we be talking about in a year?
In a year,
I
think in a year from now, we'll have a lot more knowledge on things that we think will work and not work. A year from now, I expect the error rates on the hardware to go down by another 50% or so. A year from now, we'll have more partners in this space, more companies making inroads. But in terms of practically applied quantum, I don't think a year from now we'll see much difference.
I look forward to that conversation. Thank you so much. This is the AI Summit New York.